want to have a critical section, we can do like this, and then only one thread is allowed to execute the code here. So it is the code that we protect. Atomic updates can be done using this construct, and we can insert an explicit barrier, but recall there is an implicit barrier at the end of each parallel region. The master thread performs the sequential code between the parallel regions, and if we want only the master to do some work, I mean in a parallel region, then we can do like this. And if it doesn't matter which thread it is that does something, then we can use single. And there is actually another difference between these two constructs, and it is that after this there is an implicit barrier, but not after this. Oops. Okay, there are mutex in OpenMP, but I will not talk about them. And the memory consistency model is weak ordering. So when we use these directives that we have seen, then the compiler must insert synchronizations to comply with the weak ordering, as we saw in a previous lecture. It was invented by Michel Dubois at the University of Southern California in Los Angeles in 1986. Okay, we can create a for loop without an implicit barrier, and then we use no wait. And then to get the caches consistent, we have to use the flush directive, and then we write the set of variables that should be written back. So, how safe is it to use OpenMP? Is there a risk that the source code that we develop becomes obsolete due to non-existing support? I would doubt that seriously. There is a non-profit consortium at this address, and the two main C++ compilers support OpenMP, and a large number of very large companies. A large number, that's a matter of interpretation, but some companies are really big here, so it's safe to use OpenMP as the way of parallelizing programs without the risk of making obsolete source code. Okay, AppSoft, they create Fortran compilers, and the others are well known. PathScale, compiler company as well. Portland Group, also a compiler company that we will use in this course. They were bought by NVIDIA. And PathScale produced the compilers for ARM and for AMD. One of the designers of actually this PathScale compiler, it originates from Silicon Graphics, the company that created OpenMP from the beginning. And when that company had some problems, the compiler engineers decided to open source their compiler and bring the source to their next job, which was a very clever thing. So the Silicon Graphics compiler is available as open source, and it's really good code to study. Why? Well, it's clearly written, and they have very good references to the compiler literature. So, okay, enough of that.